National Electrical Code Section 110.26 dictates how electrical equipment must be installed. Crucially, it emphasizes two key principles. Firstly, the equipment must be readily accessible, and secondly, it must be capable of being de-energized for maintenance or repair. Let's break down each of these aspects. Readily accessible, as defined by the National Electrical Code, means capable of being reached quickly for operation, renewal, or inspections without requiring those to whom ready access is requisite to actions such as to use tools, to climb over or remove obstacles, or to resort to portable ladders, and so forth. Consider the context of mounting an electrical starter in the ceiling. The code does not impose a blanket prohibition on such installations. Instead, it focuses on the accessibility of the equipment. The critical question is this: can the starter be easily reached without undue difficulty? If a ladder is routinely required to access the starter, the determination of ready accessibility hinges on several factors. Consider how frequently access is needed. Is it for routine maintenance, occasional inspections, or emergency repairs? The more frequent the need for access, the more important it is to ensure that the ladder access is convenient and unimpeded. Think about the type of ladder required. A permanently installed ladder or a readily available rolling ladder is preferable to a cumbersome extension ladder that requires two people to handle safely. Examine the surrounding area. Is there ample space to position the ladder securely and work comfortably? Obstructions such as pipes, ducts, or other equipment can hinder access and increase the risk of accidents. Now let's turn to the requirement for de-energization. The National Electrical Code mandates that electrical equipment must be capable of being disconnected from its power source for maintenance or repair. This is typically achieved through a disconnect switch or circuit breaker located within sight of the equipment. The disconnect switch or circuit breaker must be readily accessible and clearly labeled to indicate its purpose. When mounting a starter in a ceiling, it is essential to ensure that the disconnect means is also readily accessible. This might involve installing a remote disconnect switch at a more convenient location, such as near the control panel or at floor level. Consider the implications of working on energized equipment. In general, it is always safer to de-energize equipment before performing any maintenance or repair work. However, there may be situations where de-energization is not feasible or would create an unacceptable hazard. In such cases, it is crucial to follow strict safety procedures, including the use of personal protective equipment and the implementation of lockout-tagout procedures. Remember that the National Electrical Code is a minimum standard. Local codes and regulations may impose additional requirements. It is always advisable to consult with a qualified electrician or electrical inspector to ensure compliance with all applicable codes and standards. In summary, when considering mounting an electrical starter in the ceiling, carefully evaluate the accessibility of the equipment and the means of de-energization. Ensure that both are readily accessible and comply with all applicable codes and standards. Now let's delve deeper into the practical considerations of applying National Electrical Code Section 110.26 to ceiling-mounted electrical starters. We'll explore specific scenarios, common challenges, and best practices to ensure compliance and safety. Firstly, consider the height of the ceiling. The higher the ceiling, the more challenging it becomes to access the starter. A standard 8-foot ceiling presents less of a challenge than a 20-foot ceiling. When dealing with high ceilings, it is essential to use appropriate ladder safety techniques. Ensure that the ladder is properly sized for the height of the ceiling, that it is placed on a stable surface, and that it is properly secured to prevent slipping or falling. Secondly, think about the type of work being performed. Routine maintenance tasks such as inspecting connections or tightening screws may require only brief access to the starter. However, more complex repairs or troubleshooting may require extended periods of work. In such cases, it is important to provide adequate lighting and ventilation to ensure a safe and comfortable working environment. Thirdly, take into account the potential for future modifications or upgrades. If the electrical system is likely to be modified or expanded in the future, it is wise to plan ahead and provide extra space and access for future work. This might involve installing a larger enclosure or providing additional conduit runs. Fourthly, consider the impact of the environment on the equipment. Ceilings can be dusty, dirty, and humid environments. It is important to select equipment that is rated for the specific environmental conditions. This might involve using an M4 enclosure to protect the starter from dust and moisture. Fifthly, ensure proper labeling and documentation. Clearly label the starter and its associated disconnect switch with the appropriate voltage, amperage, and other relevant information. Maintain accurate documentation of the electrical system, including wiring diagrams, panel schedules, and equipment specifications. Now, let's address some common challenges associated with ceiling-mounted electrical starters. One common challenge is limited space. Ceilings are often crowded with pipes, ducts, and other equipment, making it difficult to find a suitable location for the starter. In such cases, it may be necessary to relocate existing equipment or to use a smaller starter. Another challenge is access to power and control wiring. It may be necessary to run new conduit or cable to the starter location. Ensure that all wiring is properly sized and installed in accordance with the National Electrical Code. Another challenge is coordination with other trades. It is important to coordinate the installation of the starter with other trades such as HVAC and plumbing to avoid conflicts and ensure that the work is completed safely and efficiently. Now, let's discuss some best practices for installing ceiling-mounted electrical starters. Firstly, always de-energize the circuit before working on the starter. This is the most important safety precaution you can take. Secondly, use appropriate personal protective equipment, including safety glasses, gloves, and hearing protection. Thirdly, follow the manufacturer's instructions for installing the starter. This will ensure that the starter is properly installed and will operate safely and reliably. Fourthly, inspect the starter regularly for signs of wear or damage. Replace any damage to worn parts promptly. Fifthly, keep the area around the starter clean and free of debris. This will help to prevent overheating and other problems. Remember that the National Electrical Code is a living document that is constantly being updated. It is important to stay up to date on the latest changes to the code. Consult with a qualified electrician or electrical inspector if you have any questions about the code. Installing electrical equipment in ceilings can be a safe and effective way to save space and improve the appearance of a building. However, it is important to follow all applicable codes and standards to ensure that the installation is safe and reliable. By following the guidelines outlined in this discussion, you can help to ensure that your ceiling-mounted electrical starters are installed correctly and will operate safely for many years to come. Let's further clarify the interpretation of readily accessible as it pertains to electrical equipment mounted in ceilings. The National Electrical Code provides additional guidance on this concept, and understanding these nuances is crucial for ensuring compliance. The term readily accessible is not simply about physical reach. It also encompasses the ability to safely and easily perform necessary tasks such as inspection, maintenance, and repair. Consider the tools and equipment required to perform these tasks. If specialized tools or equipment are needed, are they readily available on site? If not, the accessibility may be deemed inadequate. Think about the training and qualifications of the personnel who will be performing the work. Do they have the necessary skills and knowledge to safely access and work on the equipment? If not, additional training may be required. Consider the time required to access the equipment. If it takes an excessive amount of time to set up a ladder, remove obstacles, or gather tools, the accessibility may be considered inadequate. The National Electrical Code also addresses the issue of obstructions. Obstructions can include anything that impedes access to the equipment, such as pipes, ducts, structural members, or stored materials. If obstructions are present, they must be removed or modified to provide clear and unobstructed access to the equipment. In some cases, it may be necessary to install a permanent platform or walkway to provide access to the equipment. This is particularly common in industrial settings where equipment is located high above the floor. The National Electrical Code also addresses the issue of lighting. Adequate lighting is essential for safely accessing and working on electrical equipment. If the existing lighting is inadequate, additional lighting must be provided. This might involve installing a permanent light fixture or using a portable work light. The National Electrical Code also addresses the issue of ventilation. Adequate ventilation is essential for preventing overheating of electrical equipment. If the equipment is located in a confined space, ventilation must be provided to remove heat and prevent the buildup of flammable gases. In some cases, it may be necessary to install a ventilation fan or other cooling device. Remember that the interpretation of readily accessible is ultimately up to the authority having jurisdiction, often referred to as the AHJ. The AHJ is the local electrical inspector or other official who is responsible for enforcing the National Electrical Code. The AHJ has the final say on whether an installation meets the requirements of the code. It is always a good idea to consult with the AHJ before installing electrical equipment in a ceiling or other location where accessibility may be a concern. The AHJ can provide guidance on the specific requirements that apply in your area. In addition to the general requirements for accessibility and de-energization, the National Electrical Code also contains specific requirements for certain types of electrical equipment. For example, the National Electrical Code contains specific requirements for the installation of transformers, panel boards, and motor controllers. These requirements are designed to ensure that the equipment is installed safely and will operate reliably. It is important to consult the National Electrical Code to determine the specific requirements that apply to the type of equipment you're installing. The National Electrical Code also contains requirements for the grounding of electrical equipment. Grounding is the process of connecting electrical equipment to the earth. Grounding helps to protect people from electric shock and helps to prevent damage to equipment from electrical surges. It is important to properly ground all electrical equipment in accordance with the National Electrical Code. The National Electrical Code also contains requirements for the overcurrent protection of electrical equipment. Overcurrent protection is the process of protecting electrical equipment from damage caused by excessive current flow. Overcurrent protection is typically provided by fuses or circuit breakers. It is important to properly size and install overcurrent protection devices in accordance with the National Electrical Code. The National Electrical Code also contains requirements for the wiring of electrical equipment. The National Electrical Code specifies the type and size of wire that must be used for different types of electrical circuits. It is important to use the correct type and size of wire to ensure that the electrical system operates safely and reliably. The National Electrical Code also contains requirements for the installation of electrical boxes and conduit. Electrical boxes are used to protect electrical connections. Conduit is used to protect electrical wiring from damage. It is important to properly install electrical boxes and conduit in accordance with the National Electrical Code. The National Electrical Code also contains requirements for the labeling of electrical equipment. Electrical equipment must be labeled with the appropriate voltage, amperage, and other relevant information. This information is essential for safely operating and maintaining the equipment. Remember that the National Electrical Code is a complex and comprehensive document. It is important to consult the code and to seek the advice of a qualified electrician before installing any electrical equipment. By following the requirements of the National Electrical Code, you can help to ensure that your electrical system is safe and reliable. Furthermore, always consider the long-term maintenance implications when deciding on the mounting location of electrical starters. While initial accessibility might seem adequate, future modifications to the building or changes in work practices could render the location less accessible over time. For instance, new ductwork or piping could be installed that obstructs access to the starter. Similarly, changes in safety regulations might require the use of more elaborate scaffolding or lifting equipment, making access more difficult and time-consuming. It's also crucial to consider the potential for environmental factors to degrade the equipment over time. Ceilings, particularly in industrial settings, can be prone to dust accumulation, moisture, and temperature fluctuations. These factors can accelerate the deterioration of electrical components and necessitate more frequent maintenance. In such cases, it might be prudent to choose a more protected location, even if it requires additional conduit runs or wiring. Moreover, the availability of qualified personnel to perform maintenance and repairs should be taken into account. If the ceiling-mounted starter requires specialized knowledge or skills to service, and such personnel are not readily available, it might be more practical to locate the starter in a more accessible location where it can be serviced by a wider range of technicians. When assessing the accessibility of a ceiling-mounted starter, it's also important to consider the potential for emergency situations. In the event of a fire or other emergency, it might be necessary to quickly de-energize the starter to prevent further damage or injury. If the starter is located in a difficult-to-reach location, it could delay the response time and exacerbate the situation. Therefore, it's essential to ensure that a disconnect switch or circuit breaker for the starter is readily accessible, even in an emergency. In addition to the National Electrical Code, other codes and standards might also apply to the installation of ceiling-mounted electrical starters. For example, local building codes might specify requirements for fire resistance, ventilation, or seismic bracing. It's important to consult with the local authorities to determine which codes and standards apply in your area. Ultimately, the decision of whether or not to mount an electrical starter in a ceiling is a complex one that requires careful consideration of a variety of factors. By taking into account the requirements of the National Electrical Code, the potential for environmental degradation, the availability of qualified personnel, and the potential for emergency situations, you can make an informed decision that ensures the safety and reliability of your electrical system.